This is my lab, the natural habitat of three unusual subjects, which we have closely observed for the past episodes. I am Victor Titonius, and I bring you another exciting adventure in science. Perhaps some music would add to the drama of my introduction. Never mind. I firmly believe in the telegenicity, the uniqueness, the X factor of science, without the frills. Okay, let's get to it. Today's topic is protection against chemicals, which you would expect each of these three non-woven coveralls to offer. All types of chemical protective clothing need to comply with European standards. Their properties and protection levels are indicated on their labels by this EC marking. The standards also include tests on chemical protection. I wish to focus on two of these tests, the EN ISO 6530 and the EN ISO 6529. Sorry, that's force of habit. That means the penetration and permeation test. Maybe I need to clarify those terms as well. In both cases, we are conducting a test with a chemical in its liquid state. This is penetration. It is the process of a substance, in this case a liquid, penetrating a fabric by passing through the pores or holes of that fabric. It is very much a physical process. Permeation, on the other hand, is sort of. Okay. My test subject is exaggerating just a little bit. Permeation is a chemical process in which the molecules of a hazard pass through a fabric. Molecules are absorbed as they come into contact with the surface. Then they diffuse through the material and are desorbed on the opposite surface. You might say permeation is a much sneakier process than penetration, as it is less obvious visually and takes more time. Allow me to illustrate how the tests are performed. This is penetration. The fabric is laid in an inclined half pipe or gutter with some absorbent material underneath. 10 milliliters of a liquid chemical is poured onto the fabric. The liquid either runs down into a collection beaker or it penetrates the fabric. After 1 minute, the amount of liquid that has penetrated the fabric is determined by measuring the weight change of the absorbent material. The amount repelled by the fabric is what has been collected in the beaker. This is how we test permeation. We expose the test material to a certain amount of chemical liquid and then measure how long it takes for the molecules to break through the barrier. Hence, the result of this test is 1, a number of minutes, ideally as high as possible, and 2, the amount of a chemical that went through the fabric. All coverall material need to meet a minimum standard of their class in terms of penetration and permeation. As far as penetration is concerned, the results of our three test subjects are very close together, so any of those appear to be a good choice. But, being a scientist of the world, I force myself to look beyond lab test results. Now, the penetration test only exposes the material to hazardous chemicals for 1 minute. Surely any job people perform wearing this coverall takes more than 1 minute. You expect to be protected from chemical hazard for as long as possible. So in this respect, the standard isn't really all that telling. Permeation is a measurement that is much more relevant to protect people in the real, everyday use of a coverall. Why? The actual permeation breakthrough time gives an indication as to whether the fabric offers an appropriate chemical barrier or not. It's indicative of how long it takes before chemical starts appearing on the inside surface. Mind you, we're talking about an unpressurized environment at approximately 23 degrees centigrade. At a higher temperature, chemicals will take less time to permeate. Depending on the toxicity and hazard of the chemical, you can use the breakthrough time to evaluate whether the fabric can act as a barrier for the time your work will take. This is not easy, but there are experts, like myself, around to advise you on this. Selecting a fabric that offers a breakthrough time of over 8 hours with the chemical you need to be protected from is already a safe starting point. Expert advice is definitely necessary when you need protection against a mixture of hazardous chemicals, as the characteristics of the mixture can be very different from their constituents individually. Okay, guys, may I have your attention for a minute? Well, taking their samples isn't getting any easier, and comparing their permeation characteristics took 8 hours, thanks to Tyvek. Let's compare microporous film with Tyvek first. As you can see here, we had to wait for 8 hours, and the chemical hadn't reached the normalized breakthrough time yet. We performed the permeation test with a 40% sodium hydroxide and with an 18% sulfuric acid, two commonly used chemicals in industry. We diluted the sodium hydroxide and lowered the concentration to a mere 10% for the microporous film. But still, none of the samples came anywhere near the permeation breakthrough time of Tyvek. Our SMS samples have gaping big holes, which are nice for comfort, but unfortunately make them perform disgracefully when it comes to chemical permeation. So exciting, isn't it? I feel the conclusion of this episode is crystal clear. All three coveralls perform well when it comes to penetration, the visual danger. But a more real danger is out there. Permeation is invisible, and it may strike after a certain period of time if you are not sufficiently protected. In terms of permeation resistance, Tyvek is the superior and safest choice by far. This is explained to a large extent by its unique structure, so I kindly invite you to have a look at that episode if you haven't done so already. And if you still doubt me, science is within your own reach. Simply pour some cola or vinegar on a piece of material. Give it a few hours. It will permeate in the same way as a chemical solution. See how long it takes until it shows on the other side. Perhaps I can quickly demonstrate this for you. Anyone care for a cola?